On February 28, 2017, at 9:37 in the morning, an engineer at Amazon sat down to fix a slow billing system. Routine maintenance. The kind of task his team had done 100 times before. He opened a terminal, typed a command from the official playbook, and made a typo. A few wrong characters. That's all. Within minutes, Slack stopped working. Trello went dark. Medium, Quora, SoundCloud failing, one after another. Smart homes stopped responding to their owners. News sites lost every image. And the website whose only job is to tell you whether other websites are down, also down. This is the story of how one typo at Amazon broke half the internet, and why it could absolutely happen again tomorrow. Here's something most people never think about. The internet doesn't live in the air. It's not a cloud floating above us. It lives in buildings, enormous, windowless warehouses packed with servers, humming away in places you've never visited. And a shocking amount of the internet lives in buildings owned by one single company, Amazon. Most people know Amazon as the shopping site, but Amazon's real money machine is something most of its customers have never seen. Amazon Web Services. AWS, it's the invisible landlord of the modern web. Netflix runs on it. Airbnb runs on it. Reddit, Slack, Pinterest, millions of companies, from tiny startups to governments, rent their computing power from Amazon instead of building their own. And the crown jewel of AWS is a service with a boring name. S3, Simple Storage Service. Think of S3 as the internet's hard drive. Every image you scroll past, every file you download, every profile picture, every app backup, chances are, it's sitting in an S3 bucket somewhere. By 2017, S3 was storing trillions of objects and serving millions of requests every second. But here's the detail that matters for our story. A huge share of all that data lived in one legendary location, a cluster of data centers in Northern Virginia, known as US East 1. It's the oldest region in the cloud, the default choice, the place where half of Silicon Valley's infrastructure quietly lives. If the internet has a heart, it beats in Virginia. Which raises an uncomfortable question that, in 2017, almost nobody was asking. What happens if the heart skips a beat? February 28th started as a boring Tuesday. Inside the S3 team, there was a small, unglamorous problem. The billing system was running slower than it should. Not broken, just slow. The kind of internal annoyance that customers never even hear about. A team was assigned to debug it, and the plan was completely standard. Take a small number of servers offline to isolate the problem. There was an official playbook for this, a pre-approved, step-by-step procedure. This wasn't a cowboy move. This was the safe way to do it, the way it had been done many times before. So an authorized engineer, someone whose job was to do exactly this, opened a terminal and typed the command to remove a few servers from the billing subsystem. But one of the inputs in that command was wrong, a typo. And the tool did exactly what it was told. Instead of removing a small handful of servers, it removed a massive chunk of capacity, including servers that had nothing to do with billing. Among the casualties were two subsystems that S3 cannot live without. The first, the index subsystem, the giant table of contents that knows where every single object in the entire region is stored, every file name, every location. The second, the placement subsystem, the part that decides where new data should go. Both went down, and in that moment, S3 and US East 1 didn't just slow down, it forgot where everything was. Now here's the detail that turns this from an accident into a lesson. Those systems were designed to be restarted, but they hadn't been fully restarted in years. S3 had grown so much, so fast, that nobody actually knew how long a full restart would take. Amazon, the company running the infrastructure of the modern internet, was about to find out, live, with the whole world watching. At first, the failures looked random. Slack messages stopped sending in the middle of workday conversations. Trello boards wouldn't load. Quora, Medium, SoundCloud, Docker down. News sites suddenly lost every image. Apps logged people out and wouldn't let them back in. Smart light bulbs and thermostats stopped listening to their owners, because in 2017, even your light switch talks to Virginia. Within the hour, everyone in tech knew something big was happening. So they did the obvious thing. They checked the AWS status dashboard, the official page whose entire purpose is to tell the world which Amazon services are healthy. Every light was green. According to Amazon's own dashboard, everything was fine. Because, and I promise this is true, the dashboard's warning icons were stored in S3. The system for reporting that S3 was down could not report it because S3 was down. Amazon eventually had to use Twitter to tell the world about the outage. Meanwhile, inside Amazon, engineers were staring at the scariest progress bar in the world. The index subsystem was restarting for the first time in years, slowly crawling through the metadata of trillions of objects, checking its own records for integrity. There was no shortcut, no magic fix, nothing to do but watch it crawl, while the internet burned. In total, the outage lasted around 4 hours. 4 hours might not sound like a disaster until you count the cost. Analysts estimated that S&P 500 companies alone lost around $150 million, and the real number across the whole economy, nobody knows. The strangest part was who got hit. Websites that had never heard of the affected companies went dark because some tiny piece of them, a font, a payment script, a single image, happened to live in a bucket in Virginia. Companies discovered dependencies they didn't know they had. Half the internet, it turned out, shared a single point of failure, and it took exactly one typo to find it. Then Amazon did something genuinely rare for a trillion-dollar company. They told the truth. Within days, they published a detailed public post-mortem, no vague, minor technical issue, no corporate fog. Here's what happened, here's why, here's what we're changing. And what they concluded is the reason this story is worth telling. They didn't fire the engineer. They didn't even blame him, because the real failure wasn't human. The real failure was building a tool where one person with one typo could remove enough servers to take down the most important data center region on Earth. Humans make typos. That's what we do. A system that turns a typo into a global outage is a badly designed system. So they redesigned it. The capacity tool now removes servers slowly, with hard safety minimums. No matter what you type, it will refuse to go below the level that keeps the system alive. The status dashboard was moved off the infrastructure it was supposed to monitor. The giant subsystems were carved into smaller cells, so that no restart would ever be that terrifying again. But the deeper problem, the one no post-mortem can fix, is still with us. The cloud is not a cloud. It's buildings in specific places, run by a handful of companies. Roughly a third of the cloud still runs on AWS, and US East 1 is still its beating heart. It stumbled again in 2020. Again in 2021, taking down streaming services, smart doorbells, even airline check-ins. We built a decentralized network, and then quietly piled it all into a few very centralized basements. One engineer, one command, one typo, that's all it took in 2017. The question isn't whether something like this will happen again. The question is, what else is one keystroke away? If you enjoyed this story, you'll love the one about the developer who deleted 11 lines of code and broke the internet in a completely different way. It's right here. New tech disaster stories every week. Subscribe before the next outage.